All right, so we've got a ton of fascinating stuff to dive into about the solar system.
Yeah, it's quite the story.
It really is, and it's changed so much, over the centuries, like how we used to think about it.
Oh, absolutely. I mean, going from that Earth-centered view to like our modern understanding,
It's a huge shift.
it is. It's a massive shift in thinking. Yeah.
For centuries, we were all about Ptolemy and his Earth-centered model, right?
Right. Everything revolved around us, literally.
And it's wild to think, even back then, you had folks like Aristarchus way back in ancient Greece.
Yeah, he was ahead of his
He
time.
was proposing a sun-centered system, but,
It just wasn't clicking. Not yet.
it took a while.
It took centuries, and then someone like Copernicus comes along.
Copernicus, yeah, in the 16th century really
Yeah.
shook things up.
His book, De Revolutionibus Orbium Celestium, really threw a wrench in the works.
It's amazing how one book can kind of change everything.
It's a domino effect,
Okay.
really, leading us to the understanding that we have today, right?
Right.
Like, the solar system formed from a nebula.
A nebula, so we're talking about a gigantic cloud of, what, dust and gas.
Exact, and I mean gigantic, like beyond our imagination, just hanging out in space, and then
And that,
about 4.6 billion years ago, boom, this nebula starts to collapse.
what caused that?
Well, it could have been a few things, but one idea is the shockwave from a nearby supernova.
Okay, so like a cosmic push.
Yeah, something like that, and as this nebula collapses, it starts spinning.
And spinning faster and faster, right? Like when you see a figure skater pull their arms in,
Precisely. It's that same principle.
Oh.
And this spinning, it flattens the nebula into a disk.
with most of the stuff going towards the center.
Right, all that material getting pulled in, the pressure building, the heat rising, and
It
eventually
ignites.
it ignites. And that's how our sun was born.
Okay, so we've got our star, the sun, blazing away. What about the planets? How do they form from this swirling disk?
So in the outer regions of this disk, things are a little cooler, a little calmer, right?
Mm-hmm.
The material out there, it doesn't get sucked into the sun as quickly.
It's got more room to breathe.
Exactly. And this is where things get interesting, because out here, dust and gas start to clump together.
They're like, hey, let's stick together.
And they form these bigger and bigger bodies. We call them planetesimals.
Planetesimal, so like baby planets.
Yeah. Think of them as the seeds of planets, just tiny little things, pebbles really,
Mm.
gradually getting bigger over millions of years.
And those eventually become the planets we know and love.
Well, some of them, but here's where things get even more fascinating. The closer you are to the sun, the hotter it is,
Yeah,
right?
makes sense, closer to the fire.
So in the inner region of the disk, only the toughest stuff survives. Things with really high melting points like rock and metal.
Okay, so that's where we get those rocky terrestrial planets, Mercury, Venus, Earth, our home sweet home, and of course Mars.
Exactly. And then you have the outer region, much farther away, much cooler. Things are different out there.
So different planets.
Different planets, different composition, because now not only can rocky material clump together, but so can ices.
Ices, like water ice.
Water ice, methane ice, ammonia ice, all sorts of frozen stuff. And gravity can pull these together from much farther away.
So you get these massive planets, the gas giants, Jupiter, Saturn, with those beautiful rings, Uranus and Neptune.
It's amazing how the temperature gradient, that difference in heat, shapes the entire solar system.
Totally. So the inner planets are like small and dense survivors of a cosmic oven, and the outer planets are these giants with rings and moons and
It's like two different worlds, but formed from the same swirling cloud of dust and gas.
so cool. Now let's zoom in a little closer on these planets. Mercury, the smallest, closest to the sun. What's its deal?
Well, Mercury is a bit of an enigma, almost no atmosphere to speak of, and its surface, covered in craters, kind of like our moon.
It's like it's been through a lot.
It has. And then there's Venus, our next-door neighbor, shrouded in mystery.
It's got that thick, heavy atmosphere, right?
Oh, yeah, and we're talking toxic, mostly carbon dioxide, creating this insane greenhouse effect.
It's like Earth's evil twin, similar in size, but those surface temperatures, wow.
Hot enough to melt lead.
Yeah, thank you.
And then, of course, there's Earth, our home, the pale blue dot, a haven in the vastness of space.
Perfect temperature, liquid water, breathable atmosphere. We really lucked out.
We did. We really did. And last but certainly not least, Mars, the red planet, capturing our imagination for centuries.
Always a favorite.
It's got that thin atmosphere, that cold, dusty surface, those polar ice caps.
And those two little moons, Phobos and Deimos.
Easy to remember, right? And then, of course, we have those gas giants. Jupiter, the king of the planets.
Jupiter's massive, right?
The largest planet in our solar system, known for its swirling storms,
Yeah.
especially that great red spot.
That thing's been raging for centuries.
Yeah, it's a monster storm. And then there are those rings, faint, but they're there. And the moons?
It's got a ton of moons, right?
Over 75 at last count. Four of the biggest, Io, Europa, Ganymede, Callisto. They're fascinating worlds in their own right.
Okay, we'll have to come back to those another time. But for now, what about Saturn? The rings.
Ah, Saturn, the ringed beauty, and those rings are something else. Countless particles of ice and rock.
It's like a cosmic disco ball.
And the moons. Titan, with its dense atmosphere and methane lakes, Enceladus, spewing water vapor from its south pole, it's mind-blowing.
Wow, so much to explore out there. Okay, now we're heading out even further to the ice giants, Uranus first.
Uranus is tilted on its side, almost completely. Yeah, which makes for some crazy seasons, and its moons are all named after Shakespearean characters.
A planet fit for a king, or at least a playwright. And finally, Neptune, the blue giant.
Neptune's blue because of methane in its atmosphere, and it's got its own set of rings, fainter than Saturn's, but still, and those moons.
Triton is the one that orbits backwards.
Yeah, like a rebellious teenager going against the flow.
So we've got the inner planets, the outer planets, and then all this other stuff. Asteroids, comets, dwarf planets, and those mysterious regions beyond Neptune, the Kuiper belt, the Oort cloud.
Call that to take in, right?
It is, but it's fascinating stuff. I think we need to take a break and come back to those other objects, those remnants, in our next deep dive.
Definitely, there's a lot more to uncover.
All right, so we're back, and we're ready to tackle those other objects in our solar system, the ones beyond the 8 planets.
It's like exploring the solar system's attic, full of these fascinating leftovers.
Leftovers, remnants, yeah. Where do we even begin?
Well, let's start with the asteroid belt, out there between Mars and Jupiter.
Oh, yeah, the asteroid belt. Isn't that where, like, most asteroids hang out?
It's a popular spot. It's this huge ring, this donut-shaped region with millions of asteroids.
Millions. Wow. So what exactly are asteroids? Where did they come from?
So picture this. The solar system is forming, right? This massive cloud of gas and dust collapsing, creating the sun and the planets.
Okay, got it. The nebular theory.
Exactly. But not all of that material ended up forming planets. Some of it, well, it's just out there.
Like cosmic leftovers.
Exactly. And those leftovers, they clump together, forming these rocky, metallic, sometimes icy bodies, and those, my friend, are asteroids.
So they're like the scraps from building a house, except on a cosmic scale.
That's a great way to put it. And these scraps, they range in size from tiny pebbles to, hundreds of miles across.
Wow, that's a big range. So are all asteroids in the asteroid belt, or can they be found elsewhere?
Good question. The asteroid belt is definitely home to a lot of them, but their orbits can get nudged, by the gravity of planets, especially Jupiter.
Jupiter, the big guy, throwing its weight around.
Exactly. So
No.
sometimes asteroids get flung out of the asteroid belt and end up on these crazy journeys around the sun.
Okay, that makes sense. Now, what about these other terms I hear, like meteoroids, meteors, meteorites? What's the difference?
It's all about location and, well, what happens to them. Imagine a big old asteroid minding its own business in the asteroid belt.
Okay, picture it.
Now, sometimes there are collisions, or maybe Jupiter gives it a gravitational shove, and chunks break off. Those chunks, those are meteoroids.
Okay, so smaller pieces of asteroids.
Exactly. Now, if a meteoroid enters Earth's atmosphere, it gets heated up, friction, and it starts to vaporize.
And that's what we see as a shooting star.
That's it. That streak of light, that's a meteor. Most of them burn up completely, but if it's big enough, part of it might survive the fiery descent and actually hit the Earth.
And that's a meteorite.
You got it. A piece of space rock that made it all the way to the ground. It's like winning the cosmic lottery.
That is pretty lucky. Okay, so from asteroids to meteoroids to meteors to meteorites. Got it. Now, what about comets? They're totally different, right?
Comets are like cosmic snowballs, is how I like to think of them.
Snowballs.
Yeah, they're made up of ice, dust, rock, all this stuff that got pushed out to the outer edges of the solar system way back when.
So they're like frozen time capsules from the early solar system.
A perfect description. And they hang out in these distant regions like the Kuiper belt and the Oort cloud, way beyond Neptune.
Okay, so if they're way out there, how do we see them?
Well, sometimes something nudges them, maybe a passing star or the gravity of a giant molecular cloud.
Like a cosmic billiards game.
Kind of.
Yeah.
And these nudges, they can send comets on these long elliptical orbits around the sun.
And as they get closer to the sun, they heat up, and that's when they get those tails, right?
Exactly. The ice and dust on the surface vaporize, creating this glowing halo called a coma.
Like a cosmic fuzzball.
And then the solar wind, it pushes this material, along with ionized gas, into those distinctive tails.
Wow, and we get to see that show from Earth.
We do.
Yeah.
And some comets are more frequent visitors than others. Like Halley's Comet, it comes back every 75 years.
Yeah, I remember seeing pictures of that when I was a kid. It was a big deal. Speaking of big deals, let's talk about dwarf planets. I'm still kind of bummed about Pluto.
I get it, Pluto's got a special place in a lot of people's hearts.
Yeah.
But its reclassification as a dwarf planet, it actually helped us understand the solar system better.
Okay, so what's the difference between a planet and a dwarf planet? They both orbit the sun, right?
They do. But a planet, it has to clear its neighborhood around its orbit. That means it's gravitationally dominant, like it's the big fish in its pond.
But Pluto, it's sharing its space with a bunch of other stuff.
Exactly. It's out there in the Kuiper belt with all these other icy objects, so it hasn't cleared its neighborhood in the same way.
So Pluto's got a roommate situation going on.
Something like that.
Yeah.
But don't underestimate Pluto. It's still a fascinating world. With its own moons, its own atmosphere, it's just not quite a full-fledged planet.
Right, okay, I can accept that. And there are other dwarf planets out there too, right?
Oh, yeah. Ceres in the asteroid belt, Eris, Makemake, Haumea. These are all fascinating worlds in their own right.
Okay, so we've got asteroids, comets, dwarf planets, these remnants from the early solar system, and they're all over the place.
Scattered throughout, and there are even more of them out in those distant regions beyond Neptune, the Kuiper belt, and the Oort cloud.
Which is where we're headed next, right? To those mysterious realms at the edge of our solar system. All right, so we're going beyond Neptune now, to the Kuiper belt and the Oort cloud. It's like we're entering a whole new realm out there.
We are. It's like we're pushing the boundaries of our cosmic neighborhood.
That.
I mean, these regions are so vast, so mysterious, and we're only just beginning to understand what's out there.
It's kind of mind-boggling to think about. So let's start with the Kuiper belt. What exactly is it?
Well, imagine this massive donut-shaped region of space extending way out beyond Neptune's orbit. That's the Kuiper belt.
A cosmic donut. I like it. So is it like the asteroid belt, but just further out and icier?
It's similar in a way. It's like this debris field of leftover material from the early solar system. But instead of being mostly rock and metal, like the asteroids in the asteroid belt, the Kuiper belt is populated with these icy bodies, comets, asteroids, and of course our friend Pluto.
Right, Pluto, the king of the Kuiper belt, or at least the most famous resident. So these icy bodies, they're like time capsules from the birth of the solar system.
Exactly. They hold clues to the conditions and the materials that were present billions of years ago when our solar system was just forming. And every now and then, something nudges one of these icy bodies out of its orbit.
And that's when we get comets streaking across the sky.
Right, exactly. Those icy wanderers putting on a show for us.
But the Kuiper belt isn't the only icy realm out there. We've also got the Oort cloud, even further out, even more mysterious. The Oort cloud, that's the one that's like a giant sphere surrounding our entire solar system.
Right, that's the one. It's like this vast cosmic bubble enveloping everything. We haven't observed it directly yet because it's so far away, but we believe it contains trillions of icy objects.
Trillions. Wow, okay. So we've got the Kuiper belt, this donut-shaped region, and then even further out, this massive sphere, the Oort cloud, both filled with these icy remnants from the early solar system. It's incredible how much is out there.
It is. And it makes you realize just how much we still have to learn about our own cosmic backyard. We've come a long way from the Earth-centered view of the universe, but with each new discovery, we're reminded that there are always more mysteries to unravel, more questions to ask, and more to explore out there.
I couldn't agree more. Well, I think we've covered a lot of ground today. From the birth of our sun to those distant icy realms beyond Neptune, it's been quite the journey.
It has, and it's just the beginning. There's so much more to discover out there, so keep looking up, keep asking questions, and never stop exploring.
Words to live by. Well said. Thanks for joining me on this deep dive today. It's been a pleasure picking your brain.
The pleasure was all mine. Until next time, keep looking up.